Dear students, today we are dealing with two numericals related to conservation of energy. What is meant by conservation of energy? We saw in one of the videos that if the work is done on an object by a conservative force, then the energy is conserved. That is, the total energy remains constant. When we mean energy here, we generally mean the mechanical energy, which is kinetic and potential. So, here in this question, a stone of mass 500 gram is thrown off the top of a cliff with a speed of 5 meters per second. If the cliff is 50 meters high, what is its speed just before it hits the ground? Now here we are provided with the initial velocity. You know, this is the case of a horizontal projectile. So this object is following a parabolic path, and just before it touches the ground, its energy is fully kinetic. Its potential energy has been completely converted to kinetic energy. So initially it had potential plus kinetic. Because it was projected with a velocity 5 meters per second, it had kinetic energy. It is placed at a height 50 meters from the ground, it had potential energy. So the top of the cliff, the object has a potential energy given by mg delta x and kinetic energy given by half mv I square. If you solve it, you get it as 500 m plus 25 by 2 m. Now, the total energy is the sum of potential and kinetic. Look at the bottom of the cliff. The bottom of the cliff, the object has only kinetic energy. The potential energy is completely converted to kinetic energy, provided the energy is not lost in any other form. We assume that the energy is not lost in any other form. So according to the conservation of energy theorem, total energy has to be constant. So half mvf square is the kinetic energy it has, which is 500 m plus 25 by 2 m. That is the sum of the energy it has at the top of the cliff. So cancelling m as it is there in all the three terms, we have vf square upon 2 equals 500 plus 25 by 2. On solving this, because when we take the LCM, it comes as vf square by 2 is 500 plus 25 by 2 becomes vf square equals 2 into 500 plus 2 into 25 by 2. Vf square equals 1000 plus 25, and we get it as, on solving, we get it as 32 meter per second. So here, though we can solve this problem with other methods, here what we have dealt with is the method using conservation of energy. Moving on to the next problem related to conservation of energy. A ball of mass 250 gram is dropped 5 meters onto a spring. How much kinetic energy will the ball have when it hits the spring? How much work will be done as the spring is compressed? If the spring constant is 250 kilonewton per meter, calculate how far the spring will be compressed. Let us look at the situations one by one. Here, look at the diagram. You have an object of mass 250 gram, which is placed at a height 5 meters above a spring. This object falls onto the spring and it compresses the spring through a distance delta x. What is the initial energy the object possesses? You know that it is at rest, so there is no kinetic energy. So here we can assume that when it reaches the ground level, the amount of kinetic energy it possesses should be equal to initial potential energy. This is as per conservation of energy principle, which is equal to mg delta x. You know it is 250 gram. 250 gram is 250 by 1000, that is 0.25 kilogram, into g is 10 into delta x is 5. So which is 12.5 joule. You should know that when you have force in Newton and energy in joule, the mass has to be in kilogram and acceleration due to gravity in meter per second square and distance in meter. Coming to the second part of the question, how much work will be done as the spring is compressed? The work done here is loss of potential energy or gain in kinetic energy. So the work that can be done on the spring will be equal to 12.5 joule, because that is the amount of energy the object has as it has moved down through a distance of 5 meters. The amount of energy it has gained as kinetic energy is 12.5 joule, which can be transferred to the spring as it is compressed. So the third part of the question, we have the spring constant 250 kilonewton. So also we know that energy given to the spring is half kx square. So we have 12.5 joule is the available energy of the object which can be transferred to the spring, which is equal to half into 250 into 1000 into x square. Now why is this 250 into 1000? It is 250 kilonewton per meter. The spring constant given is 250 kilonewton. So 250 kilonewton is 250 into 1000 newton into x square. On solving, we get 2 into 12.5 is 250,000 x square, and on solving we get x as 0.01 meter. So here we have seen two problems which deals with conservation of energy, and when we say conservation of energy, we deal with the mechanical energy, which are the potential energy and the kinetic energy. I hope the problem is clear.